This is the Brief Calculus Worksheet, Day 3. This is the one that we didn't have time for in class, and you guys are responsible for watching the video and then commenting on the video. So that's how you're going to get your points for this one. So let's look at the first example. It says complete the table and use the results to estimate the limit. Remember, a limit for us is we're looking at as the graph approaches a specific point. Here it's going to be x approaching 3. That's our x value. What height is the function approaching? So what y value is it approaching from both sides? So we're kind of saying that 3 is here in the middle, and we're looking at from the left. So this is actually the limit as x approaches 3 from the left, all of these three numbers. We're kind of looking at how that is. And the limit as x approaches 3 from the right, we're coming down from the more larger values. So we're just looking at this to see if we can determine whether or not the limit exists. So let's get a calculator. And for the top, we're plugging into, so I'm going to start at 2.9. So 2.9 minus 3, close our parentheses, divided by, open a parentheses, and then it is, I'm going to open another parentheses because it's 2.9 squared, and then plus 2.9, and then minus 12, and then close the parentheses, and then hit enter, and we get that that's 0.145 if we round to 3 decimal places. Okay, so let's do 2.99. So 2.99 minus 3, that's our top value, divided by parentheses, 2.99 squared, and then plus 2.99, and then minus 12. Close the parentheses. That's 0.143. Okay, let's look at 2.999. So 2.999 minus 3 divided by parentheses 2.999 squared plus 2.999 minus 12, close parentheses, hit enter. So that's 0.1428. So we can actually distinguish that this is a little bit different. If we go to 4 decimal places, that'd be 9 if we bump the 8 up by the 7. So now we're going to look at it from the other side. So we have that we plug in 3.1 minus 3. On the bottom, we're going to be dividing by 3.1 squared. And then plus 3.1 minus 12, close parentheses. So that's 0.141. Okay, let's look at the next one. So 3.01, and that's minus 3 divided by 3.01 squared plus 3.01 minus 12, plugging into that function each time. That's 0.143. And then let's do 3.001. Okay, so then I get 0.128 again. This time it doesn't round up because there's a 3 behind it. So if they ask us to estimate this limit, say to the nearest 2 decimal places, I would assume that it looks like it's approaching 0.14 because it is an agreement that from both sides, as x approaches 3, the y value seems to be about 0.142. So 0.14 if we round to 2 decimal places. Okay, so let's look at the next table. So we're going to be doing complete the table and use the results to estimate the limit. That's why we're allowed to round, is because it's saying we're estimating it. So this time we're approaching -2, and we're approaching it from both sides. So here's the separator between those two. That's kind of where the part we care about is. And I'm just going to try to plug these in quickly, but it is decimal, so it does take a minute. So -6 times -2.1 is going to be a positive, then minus 10, Then we take the square root of that, and then minus the square root of 2. Hit enter, because that's our numerator. And then in parentheses, or excuse me, divided by parentheses. I think I'm actually going to have to type that back in. Sorry. These calculators do not like it if your parentheses is in the wrong spot. So I'm just going to do 6 times 2.1 since we know that ends up positive. Minus 10, square root that, and then minus the square root of 2. Hit enter, and then divide parentheses. It's going to be 2.1 is negative, and then minus 2, or excuse me, plus 2. Well, we'll make it a negative 2, so that'll cancel that out. So then that makes this negative 1.98. Okay, let's do negative 2.01. So there's not really anything hard about these, you just have to type it in. So times negative 6, and then minus 10, square root, minus the square root of 2, hit enter, divide it by parentheses 2.01 that is negative, and then plus 2. So this time it's negative 2.11. Okay, let's do the last one on this part, and then we'll do the other side. Oops. 2.001 negative times 6, which is negative, then minus 10. That's all inside that first radical. Take a square root of that, minus the square root of 2. Hit enter, that's my numerator, divided by 2.001, which is negative, plus 2. So this time we get negative 2.12. So that's what it looks like we're getting closer to. So we're going to try the same thing, but we're going to use the numbers from the right side this time. So 1.9 is negative times 6, which is negative, and then we get minus 10. So it's square root of 1.4 minus the square root of 2. And then we're going to divide that by parentheses 1.9, which is negative, plus 2. And so we get negative 12.96. I'm not 100% sure that's right just because of the signs. I want to make sure that that actually got typed in correctly as I was talking. So I'm going to double check it. Never hurts to double check if one of the answers looks a little funny. Yeah, that did look funny to me. Okay, so square root of 1.9, which is negative, plus 2, which is positive. Okay, it's negative 2.31. I knew that looked a little too high, so negative 2.31. So 1.99 is negative times 6, which is negative, then minus 10, square root that, minus the square root of 2, and then divide it by the bottom. So this is negative 2.14. And then our very last one on this one, and we'll have our limit times negative 6 minus 10 square root minus the square root of 2, and then divide it by the bottom. Okay, so we're getting negative 2.12. So that looks like it is our approximate limit. And they do agree. If they did not agree from both sides, remember we would say the limit does not exist. Okay, so that's, remember, just some more examples with tables. So let's talk about this next function. It says let f of x equal x squared plus 4, which is this parabola shape here, but x can never equal 1 using this function. Instead, anytime x is 1, we let the point y be 1 as well. So this is saying if x is 1, then f of x is also 1. If f(x) is not 1, then they're graphing x squared plus 4. Now, we have a picture below, and we want to know the limit as x approaches 1. Notice this point's not in the graph spot, it's way down here, but from the left, this is approaching a height of 5. f of x is approaching 5. And from the right, f of x is also approaching a height of 5. It's just coming down instead of going up. So just because the point's not there does not mean the limit doesn't exist. The limit is what is this approaching? So the limit as x approaches 1 from both sides agrees that it is 5. Okay, let's look at the next example. So this is saying what is the limit as x approaches negative 4 from the left of 1 over x plus 4? So we need to look at that and figure it out, and we're only doing a one-sided limit, so we don't need to do an entire table. Because when you do the one-sided limit, you only care what's happening on that side. So here is negative 4. So we're thinking of that as our stopping point. We stop before we get to that because we can't plug in negative 4. That's undefined. What we care about is the limit part. So we need some stuff smaller than negative 4 if we're going to be coming in from the left. So let's say negative 3.999 and negative 3.99. Actually, I'm doing it backwards, sorry. Smaller would be negative 4.00. Yeah, because remember negative numbers. See, it's really easy to confuse this just talking about it. So negative 2, negative 3, negative 4. If we go more to the left, we're at negative 4.001. Negative 4.01 and negative 4.1. If we wanted to do the right-sided limit, then we could do the negative 3.999, 3.99, 3.9. So you just have to step away in the correct direction on your number line. So we're going to plug these in real quick and just see what this one-sided limit is. Another way you could do this one, since we didn't specify, is that you could talk about actually looking at the graph of 1 over x plus 4. So if you have the ability or you know how to graph these, that's actually a little bit easier, but the table will help. So 1 divided by 4.1, which is negative, plus 4. Okay, so that's negative 10, and I believe this is just going to keep getting bigger. So 1 on top divided by parentheses 4.01, which is negative, plus 4, and then that's negative 100, and I bet the next one's going to be negative 1,000, but we'll just double check. So 1 divided by 4. Oops. We need a parentheses. 1 divided by parentheses 4.001, which is negative, plus 4, and we get negative 1,000. So it looks like as this is headed towards negative 4, the negatives just keep getting more negative very, very quickly. They're going to get, every time pretty much you're adding another 0. So what that means is that this limit is actually approaching negative infinity, because if we got a little bit closer, say 4.0001, we added in another 0 before we put the 1, it would be negative 10,000. So it's just going to keep getting smaller and smaller and smaller. So let's look at number 5. This one we're supposed to be doing the limit as x approaches 13 from the right side. So remember, on a number line, you have 12, then 13, then 14. So we are doing like 13.001. So that's the number right after 13, or at least one number. So 13.001. And then a little farther out would be 13.01. And a little farther out would be 13.1. So let's look at those and see what they come out to. So on the top we have, let's start with 13.1. So 13.1 plus 7 divided by 13.1 minus 13, and that comes out to 201. 13.01 plus 7 divided by 13.01 minus 13, that's 2,001. And then 13.001 plus 7 divided by 13.001 minus 13. And that's 20,001. and 1. So notice as this is heading to 13 from the right, which means from bigger numbers down to 13, we're actually getting bigger and bigger y values. So this one is heading towards positive infinity. So I wanted to make sure you saw one of each where we're heading to either negative infinity or positive infinity from that one side. Okay, so number 6 kind of ties into that. So this is a graph that's sort of similar to the one you would have had for number 4. It was 1 over x plus 4. This is 1 over x minus 1. That's a rational function, which means we have undefined values. We're undefined at positive 1, so notice there's this vertical asymptote there. The limit from the left is negative infinity, because see how this is going downhill forever. It's getting smaller and smaller, smaller y values. The limit from the right, as we approach 1, our graph is getting higher and higher, so we're getting bigger and bigger. This one's approaching positive infinity. Since these are approaching different things, that means the limit does not exist. Okay, for number 7, it says determine whether the given function is continuous. If it is not, identify where it is discontinuous. Polynomials are continuous everywhere on their domain, and the domain of a polynomial is implied to be negative infinity to infinity. So yes, this is continuous on negative infinity to infinity, and that's because it is a polynomial. Okay, let's look at the next one. Number 8, describe the intervals on which the function f of x equals x minus 11 over x squared minus 121 is continuous. So we need to factor the bottom first, and this one is perfect squares, so it factors into x plus 11 and x minus 11. There are 2 discontinuities here. One of them is at x equals negative 11, and the other one is at x equals positive 11. Positive 11 is actually removable because that could be factored out. We don't actually say that it's gone, but it's just that if you factored it, then it would just be a hole. You can actually still find the limit there, but you can't say that it's continuous. And then this one is actually undefined because we can't divide by 0, so this is a non-removable. This would be a vertical asymptote. So because this one cancels or reduces, it's going to be a hole. Just to remind us of that. Because this one does not cancel, it is what we call a vertical asymptote. Okay, and then let's actually write out what this would be. So we are continuous on negative infinity to negative 11, but we don't include the number, so that's why it's parentheses. Union, we're also continuous everywhere between negative 11 to 11, and then from positive 11 to positive infinity. Okay, and I believe that is the end of this worksheet. So make sure you commented, liked the video. I mean, commenting is the only required part, but I will see you guys on class on Tuesday, ready to take your first quiz for the semester. Wednesday, not Tuesday, Wednesday's class. See you later.